Hello, so this is a revision video for IB Chemistry S2.2.6, Molecular Polarity and Dipole Moments. A molecule can be polar or nonpolar depending on whether it contains polar bonds and the molecule's symmetry. Nonpolar molecules have no permanent dipole. Now, if all covalent bonds in a molecule are nonpolar, then the molecule itself will be nonpolar. There'll be no permanent dipole. But sometimes molecules can contain polar bonds but still be nonpolar overall because they have no permanent dipole. If polar bonds in a molecule are arranged symmetrically, dipoles cancel out and the molecule is nonpolar as a result. For example, in carbon dioxide CO2, each carbon-oxygen bond is polar because there's a large difference in electronegativity between the carbon and oxygen having a partial negative charge and carbon having a partial positive charge. But because the molecule has a linear shape, the dipoles of each bond cancel out, so there's no overall dipole, so it's a nonpolar molecule. Equally, in tetrachloromethane CCl₄, each carbon bond is polar, because chlorine has a higher electronegativity than carbon, so it is partially negatively charged and the carbon partially positively charged. However, the tetrahedral shape of CCl₄ means all the individual dipoles of the carbon-chlorine bonds cancel out, meaning it is nonpolar overall despite containing polar bonds. Polar molecules have a permanent dipole. So unlike nonpolar molecules that contain polar bonds, in a polar molecule dipoles don't cancel out due to asymmetry. For example, in water H₂O, OH bonds are polar, with the oxygen partially negatively charged and the hydrogen partially positively charged. The water has a bent shape, meaning the dipoles of each OH bond don't cancel out. One side or part of the molecule is partially negative overall, and the other side partially positive. Equally, chloroform CHCl₃ is also a polar molecule, because the carbon-hydrogen bond in it is nonpolar, but the carbon-chlorine bonds are polar. As a result, the dipoles from the CCl bonds don't cancel out, so the molecule has an overall dipole and would be considered polar. Exam tip here. Deciding whether a molecule is polar or nonpolar can be difficult, even if it contains polar bonds. So first of all, draw the Lewis structure and then determine bond polarities using electronegativity. Then determine molecular geometry using VSEPR and consider the direction and symmetry of bond dipoles. Decide if the bond dipoles cancel out, then that will tell you whether the molecule is polar or nonpolar.